Okay. Now, just before I finish, just before I go on to compose, let me just do something really small with odd and even. So I'm telling you that fx is even and gx is odd. So I want to know fx times gx. I'll give you a minute to to write this down. I want you to tell me it should only take you 1 minute. Is fx multiplied gx even or odd? So write that down. Tell me what it is. It is odd. And the reason is, if you do the same thing as before, f minus x times g minus x, you remember you put in the minus x, what does f of minus x equal? Because it's even. What is it, yeah? fx. And what about g of minus x? Because it's odd, what's that? Minus g of x. So you can see this is the original, isn't it? Except for you have a minus in front. This makes it odd. Now this is another reason they're called even and odd functions, because if you have an even number, is that right? No, actually, it's kind of different to regular numbers, isn't it? If you have an even number and an odd number and you multiply them together, what's the result? Even. Like 2 times 3 is an even by an odd, and what's the result? It's even, yeah. Oh, okay, so that's a bit annoying. Would have been nicer if it was the same as numbers. So an even by an odd is an odd function. What about even by even? What's that? Even by even is? Even. So, like for example, if I took fx by fx, so f of minus x by f of minus x, what does that equal? F of x by f of x, which is the same as the original, so that makes it even. What about odd by odd? Even. Why? What happened that made it even here? That's it. The minus comes out twice, cancelling and giving you back the original. So here, g minus x equals minus minus gx, which is actually the original again, so it's even. So we've done even by odd, even by even, and odd by odd. Yep. Yep, because you get 2 minuses here which cancel to make a plus. But there's another reason why odd by odd should make it even as well, because if you look at this, gx by gx is the same as gx squared. So as soon as you square something, you don't care about the sign anymore, and that makes it even. Same goes for fx by fx. That's fx squared, again, even. So you have 2 reasons for it as well. Okay, next topic now. Okay. So what does it mean to compose functions? Well, you kind of did a little bit of this already, so the idea is not completely new to you. So for example, if I say fx equals, let's say, x squared, and gx equals x plus 1, and then I said f compose g of x. What does that equal? Well, in fact, all it equals is f of g of x. So you put the g function inside the f function. So for example here, what's the g function here? X plus 1. So if x plus 1 goes inside of f, what happens to it? It's squared, so the answer would be x plus 1 squared. So that's all function composition means. If I say f with g, or f compose g, all it means is you put the g inside of the f just like this. What does that remind you of that you've done recently? Where you have a function inside of a function? Chain rule. And also from semester 1, if you remember, you had to calculate f of x plus h, where you put x plus h into the function. So it's something you've seen twice before. So now we're looking at it a bit more formal. And that's really the key idea. So we'll have a look at some examples. Oh, and you probably realize this, but if not, I'll do it just in case. F compose G is not necessarily the same as G compose F. So for example, if I was to do G compose F, G compose F of X equals G of F of X, which equals G of X squared. And what does the G function do? If you remember, it just adds 1, so the answer would be x squared plus 1, which you can see is not the same as x plus 1 squared, because x plus 1 squared is x squared plus 2x plus 1. So here's an example showing you that the order is important. They're not usually the same. And again, what does that remind you of, that the order is important? Where have you seen that before? Matrices. Yeah. Okay. All right, so let's have a look at some examples then. So first example, this is really just to warm you up. Fx equals 4 minus 2x, and I ask you to calculate f of minus 8. So that would just be 4 minus 2 times minus 8, which is 20. Yes. So that's just number 1 there. So that's not even a question, really. That's just to get you started. Right, next one now. I tell you that f of x equals 2x plus 9, and then g of x equals x squared plus g of x equals x squared plus 2x plus 3. And I ask you to calculate this. So what you do first is you put the 1 inside of the g. So what does g of 1 equal? Well, that'd be 1 squared plus 2 times 1 plus 3, so that would equal 5. Yeah? Is that okay? No, it doesn't. Come on, wake up. It's not 5, what is it? 6. Then what I do with my answer 6, I put that inside of f. So now we can do f of 6 equals 2 times 6 plus 9, so that's 12 plus 9, so that's 21. So another thing that you might have noticed is that you actually read these going from right to left. The 1 goes in the G, and then the result goes into the F. And of course, if there was another function, like a H, then it would go into that. So you actually read these from right to left is the order. Yep, scroll up. Okay, next example. So I tell you f of x equals 2 plus 3x, and I want you to calculate this. F compose f of x. So in this case, there's no number to put in, so you have to carry the x each time. So this would equal f of x. So that would equal f of 2 plus 3x. Now be very careful. This now goes back into the f. So that would be 2 plus 3. 2 plus 3x. Because this is the variable. And that goes inside the f for where the x is. This is one of these things that you either get or it just confuses you. Well, it's not quite finished because I have to simplify it. 2 plus 6 plus 9x. So the answer is 8 plus 9x. Or 9x plus 8, something. Next example. So in the next one, I tell you fx equals x plus 1, and I ask you to solve this. So same deal. f of x equals 0. f of x plus 1 equals 0. And then when x plus 1 goes into f, what will we get there? X plus 1. What's next? Plus 1, yeah, equals 0. So then you get x plus 2 equals 0. Therefore, x is equal to minus 2. So a bit of colour might help here. So here the x plus 1 is going into the f, and the f is x plus 1. So this x plus 1 is going in for the x. So it's x plus 1 plus 1. Okay. Yes? Huh? I tell you in the question, solve for when f of x is 0. Now, you can't actually do number 5 yet, because I skipped a lesson. But you don't actually need it until number 5. So you can do number 5 after the next lesson, which should have been the previous lesson. Okay? So 1 to 4, and I think I've seen every possibility from 1 to 4 in past exams. I've seen number 1, 2, 3, and 4 in past exams. So make sure you do a couple from each, okay? In particular, they really like number 3 and 4 in the exam. They sometimes throw you a bone and give you question 2 as like part A, part 1 of a long question. But that would definitely be just a 1-mark question if it came up. Okay, if you can start those now, I'd say try to do 4 from each of 1 to 4. That should do it.